Okay. Dear student, have a nice day. Now we proceed to the continuation part of this NMR ko. Koi mamang da tauhiba just in the last class ko. Ngarang si miss wagre some the question khara preparation taudiya dadana taubadagi. Sida interpretation of NMR mamang da tauhiba du itang connection nungai na bani number of signal mana pi the ba what the ba adugi kaino duni sida it tell the number of different set of equivalent proton means the equivalent proton as kaino chemically equivalent oidoini magi environment mana doini having the same environment. Means akoina proton NMR or singly NMR masi proton da reflect over adugumba topic amani habisi koina nainagre sida akoina example just these are the random example we can take any example just after getting this idea means after understanding listen and know and understand haidana koi like tambirak pa jagi sinasu jaguru sinasu haibi taba tarab matungda khangna bohana ba khangna khangal kanda amutana potubu koi mahau leina isada khangan ba that means we call the accept for. Then once you have the accept tawagi sakti do leita di you can apply you can do the application, then they will get the reason. Sida ekoina what is this ketone ki first member ni there are 6 proton. All these 6 protons si environment manai middle sida magi ketone ki functioning group later other sida makoi gi sig methylic group sina the yauriba hydrogen ahum jina proton ahum jina sanari ba pic tuga sogi proton ahum jina sanari pic siga managani because these 3 and the 3 hydrogen, each 3 hydrogen have the same environment, have the same chemically equivalent. In this case, yam common ba chloroethane hydrogen here 5 hydrogen atom, but the different environment. This methylene methyl group ki hydrogen ga methylene ki hydrogen ga manade. This hydrogen, this methylene hydrogen CH2 means the proton present in this C is near the electronegative atom for one atom other than hydrogen. Right? Environment ani se manade. Sigi environment ga CH3 ki environment ga CH2 ki environment ga manade. And we mark proton 2 A and the B. So here this one may be A. This if this is A, this will be B. So my we can put as yours score. So is matungina in my point sida ko na sina A thole sina B thole. Here in this 2 chloropropane sida 2 chloropropane sida akoi gi punna proton ji 3 plus 1 plus 3 that is 7 proton, but only different proton we have A and the A last CH3 and this left CH3 have the same environment. We call equivalent magnetically equivalent proton or chemically equivalent proton. So there are 2 different proton A and the B. It means 2 NMR signal here, 2 NMR signal here, 1 NMR signal due to the one environment oiba proton amakak pange, 2 environment oiba proton pange. In the next compound sida amula asi koi benzene ring sida magi this is CH3 not koi aina e with the column e with the magi 3 si kitang masak thidokre ko. This is CH3, this is CH3, and both same the environment. We put the B proton, and all these 4 proton all these 4 proton have the same environment. We mark A proton. This is here also 2 type of chemically different proton ani phange, we will get a 2 NMR signal. And in this case, well, we have another example. This is what is this? CH3, CH2, CH2, Cl. This is what? Chloropropane. Here we have three different proton. This CH3 and this CH3, though the same, but environment is different. Here in the right wing, we have electronegative atom. In this case, in the left wing, another group. This is electron withdrawing group. This is electron releasing group. It is different environment. So this CH3 have different. So we put A, B, C. And this CH3 another environment, and this CH2 another environment, and this is another environment. We will get 3 NMR signal. In this another example, 2 NMR signal, this is methanol. CH3 and OH means this hydrogen and this hydrogen have different environment. And here also different environment, NH2 is of this NH2 and the CH2 and CH3. In the same case, similar to this 3 NMR signal. And another example, we have cyclopropane, methyl cyclopropane. Here 4 NMR because there are 4 different proton, and this in the ring we have 3 carbon, and this is CH3, another proton, and just hydrogen, another proton different from this. And this also, this is hydrogen. All these remaining are 5 hydrogen but different. But this one and this one we put the C, and this one we put the D because these are the same. That is why related to this and related to this, there are 4 different proton. We will get 4 NMR. Here, chemical shift. What is chemical shift? Means chemical shift, the separation in the position of spectral signal of the proton or hydrogen in different chemical environment from that of a reference compound. We always reference compound in the experimental work. Means to know the unknown, we use the known value. In our daily life, lekai khangdaba amda changukanda lekai dugi mida akoina lekai dugi maramda hangdoini, that means akoi akhangba amagi mateng na khangdaba koktokodoini. Mai tawna we always use reference in another tamda or the chemical shift C kainam, the shift compared to reference compound in the position of NMR absorption due to the shielding and the shielding of proton by the electron are called chemical shift. Then in the last class, I have mentioned shielding and de-shielding. That try to remember that thing. So we will proceed this part in explanation as explanation in the next slide. Come to the another topic. For measuring chemical shift of various proton, I repeat, for measuring chemical shift of various proton in a molecule, the signal for tetramethylsilane TMS is taken as reference standard value. This is because in this silicon, it is due to the low electronegativity, the shielding of the equivalent proton in this particular reference TMC is greater than most of the organic compound. Means this part is, in another sense, we put a chemically inert. Therefore, NMR signal for TMC is taken as reference, and a chemical shift for a different kind of proton can be measured related to it. And this is the formula, structural formula of the TMC. There are 12 proton in the methyl group. having same chemical environment. So this is for peak we will get, and these are the chemically inert. So chemical shift is expressed in delta value in equivalent frequency, not in Gauss. Another scale is tau or 10. We can use, there are two model of application. Then this is the modality of the peak. We can see in the real picture. Next slide. This is in a delta form. This is 0 to 10, 0 to 10, and this is tau at 10, 0 to 10. It is reversed due to this formula. We can use delta equal to tau minus 10 minus tau, or tau is equal to 10 minus d delta, like that. You can use any form. The peak represent or denote the peak. These are the peak represent or denote the different proton. Here, for example, this is what example I don't mention, but this is the some related peak that I have drawn. This is the reference peak related to this above or below this peak, no problem. But this is proton, different proton. Here, three different peak. We show particular compound having have three different proton due to this relation. So different proton and distance from TMC, the distance from TMC to peak is called chemical shift. From here to here, or here to here, here to here, these are the different distance. So we call the chemical shift, giving the position of all the proton present in the compound under study. So these are the different proton reflected in the peak in the NMR spectrum related to the TMC, and the chemical shift is can be calculated. Proton sample means then a reference sample. Okay, that is a study sample, and a proton standard or reference upon this one proton reference into 10 to the power 6. These are the standard relation. Then come to the another slide, shielding and the shielding that I have mentioned in the last class. Now we will remember some idea so that we can focus the interpretation of the NMR, the part of this particular. Let us take one example. This is chlorothiene. This is proton, another proton, another proton. Remark A and the B. Shell and this shell. Shell and this shell. The environment of the electron cloud and environment of the electron cloud is different. Means that I have mentioned in the previous slide. Secondary field align with the applied field, or opposite to the applied field. That is the reflection of the shielding, and it is shielding related to the environment of the proton under study. So uphill and downhill means due to different proton, A proton and B proton. B proton downhill, A proton uphill, lower delta value, higher delta value. This is the model of the peak related to this compound. Then this is the range of the intensity, delta value, and this is the intensity. I will show in the next slide that I have taken the image from the standard data. Here, proton A is far away from the chlorine atom, which is electronegative, then carbon, and then hydrogen. This proton that is not affected by the electron cloud of the chlorine, because this proton is far away from the having electronegative atom having electron density. Here, density, the electron cloud provide protection from external field, applied external field protection to it. That is the protection of the nucleus. That is shield. We call the shield due to the protection. And a less amount of magnetic field required and needed. Less amount of apply magnetic field required. We have to apply less amount of external magnetic field in this particular proton and require less energy due to the less magnetic field, and so less energy to flip means to spin uphill means the proton here present. And in the case of proton B, towards the electronegative atom chlorine, that is toward the electron density, having more density, and affected by the chlorine atom and generate less electron cloud means, and the external field is very much higher, does require large energy to flip, that is downfield, is away from this here, and uphill, downfield. Then come to the another slide, note. Here, one important note, it is attachment of electronegative atom to proton bearing carbon. I repeat, attachment of electronegative atom to proton bearing carbon causes the shielding effect downfield signal, that is signal at higher delta value, and another case is hydrogen bonding also decrease electron density around the proton and cause the shielding. There are two cases. If hydrogen bonding takes place, the shielding occur, and electronegative atom present also, the shielding occur. This is important things you have to remember. Now, interpretation of peak area. It is directly related, directly proportional to the number of proton, giving rise to that peak. In surrounding proton, environmental also play very important role in this particular case. So, ratio of peak area up to peak will be equal to the ratio of number of proton giving rise to those peak. This is another term for the interpretation of proton. We will focus in deep about this particular topic part. So another random example, ethanol. Here, three different proton. We put one A proton, B proton, C proton, 1 proton, 2 proton, 3 proton. That is the number of proton. Yeah, very important number of proton. Yeah, 1:2:3. In this particular case, we have two different proton. CH3, CH3 have the same environment, have chemical equivalent. We mark the A proton, and here 3 hydrogen attached to the benzene ring. Have same environment. We put a B proton. That is different category. The two type of proton, A and the B. We can mark in any this one B, this one A, like that, no problem. Here two different proton we mark here. How many A proton? 3 into 3 into, I mean 3 plus 3 plus 3 into 3, this is 9, and here 1 into 3 means 3, that is 9:3. But in the some multiple choice, 3:1 sometimes reflect in the multiple choice in CSR examination and other related examination. No problem. If you have the idea, you can give the answer. Then another splitting of signal. Splitting of signal means spin splitting or spin coupling. Like that we can mark splitting. Generally, as a whole, we see one signal, but in deep, we focus, we'll get multiplet, 2 or 3 or 5, more than one. Yeah, this is a model of the splitting, but as a whole, when we view one peak, but in deep, splitting is due to the interaction of spin of the proton with that of another proton on the adjacent carbon atom. Means adjacent the proton they matamda my interaction tong madu interaction tawgi mong do matang yengasi. An equivalent proton don't cause splitting if there are number of proton present. If they are equivalent, no split. And a single peak we call singlet. A single peak we call singlet is not observed, but a multiplet group of peak is observed. The multiplicity of the hyperfine structure depend on the number of the proton. Means the multiplet can be calculated by using the number of proton present nearby. It is reflected by the formula n plus 1 or 2n I plus 1. This is n number of adjacent proton present. Here I for hydrogen is half, it is 1 electron. That is why we put the half here. A and the B, this is repeated example, no problem. In this case, yeah, A proton and B proton. Now let us consider A proton. Means A proton. All these three have the same environment. We put A, but here 2 proton present. That is the multiplet will be 2 plus 1. That is 3. In case of B, here 2 hydrogen have same environment, but in the nearby 3 hydrogen, 2 that is in the B case 3 plus 1, we will get 4 quartet like that. And this another example, A, B, C, we mark here A, 2 proton, 2 plus 1, 3, and the B 3 plus 2 in 5, 5 plus 1, 6 sextet, and the C same to the A because 2 proton. This is not proton, 1 atom, but in the shielding here also we can focus, but in this particular splitting means spin coupling, spin interaction is very important. That is why I focus. Then one another important note means relative intensity of the individual line of a multiplet correspond to the numerical coefficient of the line in the binomial expression. This is the term. This is the these are the language, and these are the mathematical relation. So yeah, if x1 plus x to the power n, and then become 1 plus x if n is equal to 1. If n equal to 2, this will be, and the formula reflect that formula is this, means 1 x means 1. This is another signal, means another interpretation. 1 is to 2 is 2, and here 1 is to 3 is to 2. I will focus on this topic like this. Let us this is the picture I have collected. So the proton NMR spectrum of bromoethane. Proton NMR spectrum of bromoethane. Let us now. Intensity. Here A and the B. The peak value reflected here and here 1.68 delta and the 3.43 delta, the value of the A and the B. Here this is the quartet due to the methylene group, because in this methylene group there are 3 hydrogen atoms. That is why the multiplet will be quartet. This one, see that. And for the case of methyl group surrounded by methylene group, it is 2 proton, the triplet. This is the standard peak reflecting 0. No, this is the standard value. So this is the 2 important peak for this 2 important proton. Now see here methylene proton appear a quadrate at this value, and another methyl proton appear at triplet due to the number of protons surrounded, as I mentioned. This is the real peak you will observe experimentally when you do the practical during your MSc standard, no problem. And this is the model of interpretation. This is the model of interpretation. This is the model of interpretation. In this case, this is the applied field. This is the applied field, and this is another opposed, aligned, opposed. We will mark if applied field ga yamna akoigi tamina taragadi strongly reinforcing and thongani aduga moisina weakly reinforcing adigi weakly opposing, strongly opposing. We will mark the quadrate. We will mark like that. So for the methylene proton, strongly reinforced aligned toba aduga khara may arab aligned toba aduga may arab opposed toba, strongly opposed toba aina koina mention togan. Here also the triplet strongly, these are the strongly opposed, strongly aligned, reinforced, and moderately. This one, this is very important. This is no problem. See, in this case, TMS is the acronym for the trimethyl silane formula. These whose proton are arbitrarily given a chemical shape, as I have mentioned in the above part, 0.0 ppm. These are the standard form. This is the standard in proton NMR spectroscopy, and all other proton resonance called chemical shape or other proton resonance chemical shape. Measure with respect to this standard and depend on the individual electronic or chemically environment proton surrounded, and the chemical shape quoted in ppm on the diagram as shown. And these are the some part, some language, some idea you can copy. And interpretation that I have mentioned above, interpretation in terms of spin-spin coupling from the possible proton magnetic orientation for the bromomethane. Only consider the interaction of non-equivalent proton. It is this one and this one have different environment. That is why this proton and this proton are respective dimension non-equivalent. So the hydrogen atom or proton of bromomethane occupy 2 different chemical environment. So lower resolution NMR spectra should show 2 principal peak of different this one chemical shape diagram above. When mathak ta ut kibijing duni dona yang kana anate ni charak bakara idea kara aina not sengkat pada nungaina ba by one sagi for to that. Then sai box to in darkar oidre sida koina kitang reflection p ba matang yengsi. The splitting of a signal is due to the different environment of the absorbing proton not with respect to the electron, but with the respect of the nearby proton. So let us consider very important taking this particular example. Let us consider a molecule, this Cl, CH2, CH2. Here, the mutual magnetic influence between the proton A, and the B is not transmitted through the space, but through the neutron, through the electron in the intervening bond. The nuclear spin of proton A first couple, nuclear spin of proton A first couple. This is very important. So very important. Listen carefully and repeat when you try learning. The nuclear spin of proton A first coupled with the electron spin of carbon hydrogen. This is carbon hydrogen bonding present. We marked hydrogen A and these in turn coupled with carbon. We are also carbon, and then with a carbon hydrogen. This one is connection is carbon hydrogen carbon, another hydrogen nearby present. So thus the coupling is eventually transmitted to the spin of the hydrogen B nucleus to this. So signal from proton A, yeah, this is proton A because one proton nearby, 1 plus 1, that is these two environment. We select 1 plus 1, that is 2. One is align, another is opposed, uphill, downhill. And the proton B, one proton, single proton, but nearby 2 proton, 2 plus 1, that is 3. It is so triplet, 1:2:1. This is 1:2:1. Moderate, strongly opposed, strongly aligned. So, and another example we can put like this: 3 proton near present 1 proton. This is why this one for A proton and this one for B proton, because 3 plus 1 4. This is quadrat. These are the related peak. This is for B proton and this is for A proton, and another, all the protons in a molecule are equivalent. No splitting is caused. I have mentioned if there are a number of protons but they have the same environment, no splitting, one singlet. No splitting when a set of equivalent protons do not have another set of proton attached to the. Here also my koi bada yaw da taragasu lay roiduini ma masagi proton environment we bada natana masagi marakasu environment ka taragadi adu report ni. The example lama koi yengasi to butanol hydroxide as singlet appear for the proton A. A singlet appear proton because imagine acquire the proton later. That is no hydrogen attached to the adjacent. The only my hydrocarbon ki balance very far like hello proton sang from later, proton room later. And as my togna B